Alright, yeah, welcome to another series of Solar Edu with Jblot. And this week I'll be answering one of the most frequently asked questions, which is what are the differences between a lithium-ion battery and a lead-acid battery? And here I'm having two top brands. I'm having the 200 amps QUANTA lead-acid battery, and I'm having the FELICITY 10 kilowatts per lithium-ion battery. So I'll be stating three differences, which is I'll be talking about the DOD, I'll be talking about the cycle life, and I'll be talking about gravimetric and volumetric energy density. And I'm sure that this will help you to make the right decision when shopping for your battery. Thank you. Today I'll be talking about DOD, which is my first point in differentiating between a lead-acid battery and a lithium battery. What is DOD? DOD is depth of discharge. It actually means the amount of energy that can be withdrawn from the total energy of a battery. So the fact that a battery is actually 200 amps doesn't mean that you can fully discharge that 200 amps power out of it. Lead-acid battery is having a DOD of 50% and lithium battery are known for 80%. I'll expatiate more. It means that the fact that this battery is 200 amps, the only thing you can discharge completely from this battery is 100 amps, which is 50%. And for lithium battery, the fact that it's actually 10 kilowatts per hour, it means that the highest energy you can discharge from this thing is 8 kilowatts per hour, which is 80%. And we still have some premium brand that are 90%, 95% of DOD. So on the note of DOD, it will take 8 pieces of this lead-acid battery to meet up with this 10 kilowatt per hour lithium battery. On the note of DOD, I told you lead-acid discharge 50% of their power, whereas this lithium battery dispense up to 80 to 95% of its power. So that is the first difference between a lithium-ion battery and a lead-acid battery. See you in the next series. Alright, welcome to another series of differentiating between a lithium-ion battery and a lead-acid battery. The next point I'll be mentioning is cycle life. What is cycle life? Cycle life is the amount of charge and discharge a battery can take before it starts losing performance. It means that battery that has 300 cycle you can only charge and discharge the battery 300 times. Once it gets to that 300 times, it will start losing time. You start going below company specification. If you spend 5 hours before, you start decreasing to 4 hours, 3 hours, 2 hours. So the life cycle of lithium battery is about, for this brand, it's about 6,000 life cycle. While for most of this one, they are just 2,015. You can see the difference. So this is one of the major differences between a lead-acid battery and lithium battery. I'll see you in the next one. You're welcome to another series of differentiating between a lithium-ion battery and a lead-acid battery. And today I'll be discussing about volumetric energy density and gravimetric energy density. What is volumetric and gravimetric energy density? Gravimetric energy density is the amount of power stored in a system per unit mass, while volumetric energy density is the amount of energy stored in a battery per unit volume. So what this actually means, these figures are what contributes to how weighty and how bulky a battery can be. So this is actually an energy engineering term, so it might be a bit complex to explain. Alright, so what is gravimetric energy density? From the last definition, this lithium battery is actually 10 kilowatt per hour. And probably, I'm not saying this is the weight, but I'm citing as an example. Assuming this battery now is 10 kg, and we measure each of the cell. Well, technically what it actually means is that each gram inside the cell is contributing 1 kilowatt. 1 kilowatt, that is 1,000 watts per hour that each cell inside this thing is contributing. So having about 10 of it, they will contribute 10 kilowatt per hour. So in that sense, it will not be too weighty. It will not be too weighty and it will not be bulky. Now come to where we have Now coming to this lead-acid battery that weighs about 61 kg. And yet its total weight is just 2.4 kilowatt per hour. Even on the note of DOD is 1,200 watts per hour. That is why it is very weighty, very bulky compared to this lithium battery. That is why a lithium battery can be having the same weight with this battery. The amount of energy a lithium battery is holding is times 8 of this lead-acid battery. Can you get it? So the reason I said times 8 is using the logic of the DOD. I told you it's 50% energy. The energy on this lead-acid battery is just 2,400 watts per hour. Now using the DOD, it means that it's only what 1,200 energy here. And here now, the way this one is actually 10 kilowatt per hour. Let's as said that this one is 90% DOD. It means that it can only dispense what 9 kilowatt per hour of energy. You can see how volumetric and gravimetric energy density contributes to the weight and the bulkiness of our battery. Thank you. Alright, in conclusion, you can see that in terms of DOD, lithium battery is better because the lithium battery offer up to 95% DOD. And in terms of cycle life, you can see that your lithium battery will also offer you better cycle life. And in terms of gravimetric and volumetric energy density, you can see why lithium battery is so small and yet still dispenses such massive power, still having that much capacity than that bulky big lead acid battery. So if you have enough money, I would advise you go for lithium battery. It's actually the best, and to give you the best quality. Yes, it will be the best quality of service. So to contact us at Jblot Green Techs for more inquiries about solar, about installation, about solar auditing, about anything related to energy, right there. Alright, so we'll be open to welcome you on our DM, and we'll give you quality service. Alright, thank you.